everyone, Mr. Hine, and we're talking about sequences for a second day now, and there's a little bit more to know than what we've done. So let's build off what we know. So remember, the sequence is just a list of numbers, and then recall that there's two types that you need to know for this class. The first type being linear, and the second type being geometric. Linear sequences are sequences that change by addition or subtraction. Geometric are those that change by multiplication or division. So you might see here that a linear pattern could look like 3, 5, 7, 9, and so forth. Right? And the reason that is linear is because it's adding by 2. Right? And then a geometric sequence, we might see something as 3, 9, 27, 81, in which this one's not adding, because there's no number there adding, but it is actually timesing by 3. And if you use the calculator to check that, you'd see that it's true. Now, we talked about in the last video the explicit equation, which is really just the equation that we use, but instead of y equals, they use t of n to help us say we want a specific term, and we always need the starting value. Now just be careful, the starting value is not 3. This is the first number, and that's the second number. We need the 0th number. So to get the 0th number, remember that you always have to work backwards. So in this case, that first number here would be 1. So it's 1 plus 2n, because that's the pattern there that's adding 2. And over here, it would have been t of n is equal to, well, we work backwards. Say we divide by 3. 3 divided by 3 is 1 to get its starting value. And then the pattern here is times 3 to the power of n. And notice I just did a parentheses. You could put a dot there to say it's times by 3. Whatever helps you see that. Now, today, you're going to be learning something new called the recursive equation. Now, before I get into what recursive is, look at the prefix re, where re means is like, think words like repeat, to do again. Right? And that's going to help you understand this when I write it. So an example that they're going to give you is they're going to say, write the first 5 terms given the recursive equation. So the language they use is something like this, where it says t of n plus 1 equals t of n plus 3. And now you might be saying, whoa, what did you just do there? I still don't even understand t of n. Now you're throwing in n plus 1. That's okay. Let me help break this down for you. So what this is saying is t of n is a specific, number that they call n in the sequence. Okay, so we're looking at a number in the sequence. Well, what's n plus 1? Well, this is the next number, the following number. So if I look up here at 1, 3, 5, 7, 9, an example would be like, say 7 is t of n, okay? Well, 9 would then be t of n plus 1, because it's the next number. Over here, if t of n might be 3, t of n plus 1 would be the 9. It's the next number, and that's what that's saying here. So what this whole thing is saying to get the next number, what we're going to do, what it's going to equal, is the previous number, thinking about that next, and the one before would be the previous number, plus 3. So it's saying to get the next number, add 3 to the previous number, is what this is saying here. Now, notice, if I move my face so you can see that if all I said was to get next number, add 3, and I said write 5 numbers, well, there's a lot you could write. You could write 2, 5, 8, 11, 14, because that's adding by 3, right? That one works. You could write 10, 13, 16, 19. That one's adding by 3. So it's like, whoa, well, there's a lot of answers there. So which one is it? And for that reason, the fact that there's so many different answers, this is not enough information. So they always give you a second thing where they'll probably write something like this. T of 1 is equal to 13. And now that's telling us that the first number is 13. So then when we think about our sequence of numbers, the first number is 13. The second number, now how do we know what the second number is? Well, we use this fact here. To get the next number, we add 3 to the previous. So we add 3, and that's 16. To get to the next number, we add 3 again. To get to the next number, we add 3 again. That's the fourth number. And to get to the next number, you add 3 again, and there's the fifth number. And there are the first 5 terms of this sequence. Notice how we use this fact to keep adding 3. We repeated it, we kept doing it again. That's why it's called our recursive information. You keep doing it over and over again. To look at one more example to help you hopefully understand this a little bit better before you try it yourself, is say you have an example where it says t of 1 equals 6, t of n plus 1 is equal to t of n times 2. So now this is telling us, that first one's saying that the first number is 6, and then it's saying to get the next number, we're going to times 2 to the previous number. All right. So then the second number, the next number, we times by 2, now it'd be 12. The third number, we do that again, and we get 24. Fourth number would be 48. And the fifth number, and I know you can use a calculator, I just work with these numbers so much that I can do this in my head. You'll get there too one day with just more practice. And there are the 5 numbers there. So that's what recursive is when you see those 2 lines where it gives you a number and then it tells you t of n plus 1. To get the next number, this is what your pattern or rule is. Hope that makes sense. Make sure you reach out to your make sure you reach out to your teachers if you have questions, and I'm sure we'll all be ready to help you. All right, bye-bye.